Okay, so we're going to talk about graphing rational functions today. There's a couple of steps that'll make it really easy for you. So the first thing you're going to do is you're going to find the vertical asymptote, and you're going to do that by setting the denominator equal to 0. Today we're only going to have one factor in the denominator. However, in the future you may have more, and you set each of those factors equal to 0 in order to find the vertical asymptotes. To find the horizontal asymptote, you're going to do one of these two things. If the degree is greater in the denominator, and remember the degree is the highest exponent, then you're going to use the k value. If the degrees are equal, then you're going to use the ratio of the leading coefficients. You're going to plug in an x value in each section to find where the graph should be, and then you're just going to follow the asymptotes to draw on your graph. So technically I'm telling you that I really only need one correct point in each of the sections vertically of your graph. So I'll show you what that looks like. So these are the two parent functions, and we're going to talk about those first. So the first one is f of x equals 1 divided by x, and the first thing we're going to do is find the vertical asymptote. So the way that we do that is we set the denominator equal to 0, and there's nothing actually to solve, so the vertical asymptote is x equals 0. Then we're going to find the horizontal asymptote, and we find that if we look at the numerator and denominator, the degree is 1 in the denominator, which is greater than the numerator, which it doesn't have a variable, so it'd just be 0. So we're looking at the k value. The k value is this little value that's like out here, and there's nothing there, so we're assuming that it is 0. Okay, so the horizontal asymptote is y equals 0. Then I'm going to draw those in first real quick. So I'm going to draw in my vertical asymptote at x equals 0. And then my horizontal asymptote at y equals 0. Okay, and then I'm going to choose an x value in each of the vertical sections. So I'm actually going to choose, we've got x and f of x. I'm going to choose -1, just -1 and +1. So when I look at this, if I were to take 1 and plug it in, -1 and plug it in for the x, I'd get 1 divided by -1, which would just be -1. If I took 1 and plugged it in for x in the f of x function, it would be 1 divided by 1, which is just 1. So my 2 points are -1, -1, and then +1, +1. And then that last step is just to draw in the graph along the asymptote. So we've got that one there and that one there. Okay, so you're just following the asymptote. Same thing over here. You can't cross the asymptote, but you can follow it. And there, okay? Notice, this is different from any of the other graphs that we've looked at this entire year because it has multiple parts. So looking at the domain, there's going to be 2 parts to our domain. You can write this a couple of ways. So we could say -infinity, and then we stop at 0, so left to right, and then again from 0 to infinity. And we've seen this notation before. This means like and. Or you could also write it as -infinity to +infinity, x can't be 0. That's another way of writing it. I would prefer the first way, but that's just my personal preference. And then the second one, -infinity, again, we're stopping at the y value 0, and 0 to infinity. Over here, we have f of x equals 1 over x squared. So notice the only difference is that it's now degree 2 in the denominator instead of degree 1. The vertical asymptote, you just set the denominator equal to 0. So square root both sides and I get x is 0. The horizontal asymptote, I look at the denominator, it has a greater degree, so it's the k value. There's nothing in the place of the k value, so I know that it's 0. And then the last thing I would do after I plug in those asymptotes, I've got x equals 0, y equals 0. I'm going to plug in a point on either side, so -1 on the left-hand side vertically, and 1. So if I plug in -1, -1 squared is +1, and 1 divided by 1 is 1. If I plug in +1 for the x, I'd get 1 squared, which would just be 1. 1 divided by 1 is 1. So I have my 2 points, -1, 1 in each of the vertical pieces of my graph, and then I just follow my asymptotes. Notice that this one is slightly different than the first one because there are no y values that are negative. So in the first one, there are y values that were negative, and the second one there are not. So for our domain, we have -infinity to 0 and 0 to infinity. Again, you could write that the other way that I showed you. And there's really only one piece for the y values because they're all positive, so they're all above 0. So we could say 0 to infinity, or you could also write that as y is greater than 0, and I'd be fine with that. This next part is just some examples. We've got one of each kind of the parent function, so one that's going to be in opposite areas of the graph, and then one that's all going to be above or below the horizontal asymptote. So let's look at this first one. Same approach. We're going to get the vertical asymptote by setting the denominator equal to 0, which gives us x equals 4. Then we've got the horizontal asymptote, so that's going to be my k value, and this time there is a k value. It is 2. And then I'm going to graph those asymptotes real quick. X equals 4, y equals 2, and then I'm going to plug in a point in each of the vertical sections. So I'm going to plug in 3 as my x value because it's 1 to the left of the vertical asymptote, and I'm going to plug in 5 because it's 1 to the right. So if I plug in 3 minus 4 gives me -1. -1 divided by -1 is +1. Add 2, you get 3. If I plug in 5 minus 4 is 1. -1 divided by 1 would be -1. Plus 2 would be 1. All right, so I'm going to graph those 2 points. I've got 3, 3. I've got 5, 1. And then I'm going to follow my asymptotes to draw in my graph. Kind of went over that one. Obviously, don't cross it. Got a little crazy with the pen. And yeah, there we go. All right. We look at our graph to find our domain, left to right. So we've got -infinity stopping at 4. So we can't include that because it's an asymptote. And then 4 to infinity. For my range, I've got -infinity stopping at 2 and 2 to infinity. Notice that I'm using parentheses instead of like the hard brackets like this. The reason why I'm doing that is because it's not going to be equal to any of those values. Number one, you can't be equal to infinity, and then you can't be equal to the asymptote, so that's why there's a parenthesis there. All right, so over here, this last one that we're going to look at is f of x equals 1 divided by x plus 1 squared minus 4. So let's start with the vertical asymptote. We set the denominator equal to 0, so x plus 1 equals 0. So x is going to be -1 for our vertical asymptote. Our horizontal asymptote, we are looking, the degree is larger in the denominator still, so I'm looking at my k value, which is -4 in this case. So I'm going to go ahead and graph both of those. X equals -1 and y equals -4. Okay, so there we go. Now we've got to plug in our x's to find our y values. So I'm going to plug in -2 because it's 1 to the left of the asymptote, and 0 because it's 1 to the right of the vertical asymptote. So -2 plus 1 would give me -1. Square that, you get 1. 1 divided by 1 is 1. -4 would be -3. 0 plus 1 is 1. 1 squared is 1. If I do 1 divided by 1, I get 1. -4 is -3. So I'm going to graph -2, -3, and 0, -3. I'm going to follow my asymptotes. Okay. So there's my graph. And then my domain, I'm starting from the left, -infinity. I'm stopping at the vertical asymptote, which is -1. Starting back up at the vertical asymptote, going to the right to positive infinity. For the range, there's going to be only one piece because everything is above -4. So -4 to infinity, or you could also write that as y is greater than -4. Either way. So that's how you graph rational functions. That's the basis of what we are doing.